Hands on. Network is sabotaging me big time here. Guys, the network is sabotaging me big time. Can someone tell me if they heard my explanation in the live when I actually was explaining about complementary angles? Or did we miss that completely because of your network sabotage? Guys, very sorry about that. I don't know if you, because I saw that I got cut off and my network was just, I thought, because I could see like everything, it seemed like it was fine, but then I saw that there was silence and I was like, there must be a problem. So did we hear this whole explanation of complementary angles, or did we miss that? Did we all get an understanding of what complementary angles are from what I had explained, or did we miss it? Okay, you missed that, no? Okay, you missed it. Anyone else? We missed it. So must I re-explain complementary angles? Okay, I will explain again. Don't worry. Just hang on a sec, guys. It's getting hot in here. Now I just feel like, it's too much. I don't know. Maybe it's the mats that's getting me hot. But nonetheless, complementary angles, I repeat, complementary angles are angles that add up to 90 degrees. All right, I repeat, complementary angles are angles that add up to 90 degrees. So like I said, we have PQR. This angle here is 90 degrees. All right, so we know it's a right angle, no doubt. But now to be specific about these angles that add up to 90 degrees, since we know that this angle 90 degrees has been cut into two angles. One of our angles is angle Q1 and the other angle is angle Q2. But you know what? When we add these two angles and we refer to this specific angle here, we can loosely call it angle Q1. Why can we loosely call this angle Q1? The reason is we have gotten a designation, or that angle has been named as Q1. Okay, because I'm sure some of you are like screaming and you are saying, but say, didn't you say when we name an angle we go by the arms of the particular angle as it is formed joined at the vertex? So QM and QR, all right? Yes, of course, we can say this is angle MQR. I mean, that would be correct. Or we could say this is angle RQM. That's fine. But because we have this one here, this one is another way that can assist us to be able to name the specific angle. So we can call it angle Q1. Okay, thank you, Mr. N, for the rosa. So we can say this is angle Q1. We can go ahead and do that and say this is angle what? Q1. Okay, then if you look at the angle here, that is angle what? Q2. All right. Okay, so yes, that does not take away the fact that if you wanted to, you could say this is angle PQM, or you could say it's angle MQP. That's fine, you could do that. But this is angle Q2. Hello, Mrs. M. Okay, Mrs. M, hello. So we could say this is angle Q2 and that's angle Q1. Now, these two angles, remember we said complementary angles are angles that add up to 90. Doesn't angle Q1 together with angle Q2, don't they add up to this 90 degrees? That is already there? Almost definitely they do. Angle Q1 plus angle Q2 are typical examples of angles that add up to 90 degrees. Remember this box here, all right, stands for PQ being perpendicular to QR. In other words, that this angle PQR is a right angle, okay, and it's 90 degrees in other words. So we can say angle Q1 plus angle Q2 is equal to 90 degrees. So I hope that's clear now, that we can then say angle Q1 plus angle Q2 is 90 degrees, and the reason is because they are complementary angles. So we write complementary in short and we say comp angles. All right, so I hope you understand this relationship that exists between Q1, angle Q1 and angle Q2. We refer to those angles as complementary angles. Why? Because they are angles that add up to 90 degrees, as has been explained. Mrs. M, this is for grade 9, term 3. All right, I'm just getting my grade 9s started up on the term 3 work so that they can fly in term 3, no problem. So I'm kind of starting midway in the syllabus, and I'm wanting to do that so that we can do a lot of geometry during the holiday, and then we'll revert back to some of the first few concepts that are done in the beginning of the term. But for now, I want to start here so that the kids can get familiar with the geometry that they did even in grade 8. All right, so I hope we are together. So Siviwe, Lesejo, are we good? Can I move on? I remember, I'm just recalling that people had indicated, Sia, are we good? Like you'd indicated that you didn't hear me, before I got cut off and before the network went haywire. But do we now understand what complementary angles are? Okay, Lesejo says, yes, you may, thank you. So if you are we good? I don't know, Sia for life there is lifing away. Maziko, I don't know if you're still here. Mabuto, hi, I see you. Yeah, it's been a while indeed. Okay, I'm good. Okay, let's go to the next one. What are supplementary angles? Okay, description, guys. What is the description for supplementary angles? Remember, we're talking about the relationship between many angles. Okay, relationship between angles, supplementary angles. CF for life, very good. CF for life is spot on there. Angles that add up to 180 degrees. And he then says, I guess. No guessing games here. You must just tell me straight up. Be accurate. Hopefully, we must be confident now. Guessing and we need to be sure. So, CF for life, angles that add up to 180 what? Degrees. Thank you so much. That is 100% true and spot on. Angles that add up to 180 degrees. You are the man. You are the main man. Okay? Now, just to explore this and to explore it well, A, B, C We write D. ABC is a straight line. We write 1, we write 2. So I'm sure you guys know from what we had just done earlier on that straight angle is equal to 180 from here all the way to what? To there. So angle B1 is from here to this point. Does that make sense? That's angle B1 from here up until this point. I hope you guys are tlhaloganya ring, hey? It's very important to tlhaloganya. And then B2 is from here to there. All right. So together, what do these angles do? They actually are angles that lie on a straight line. They form a straight angle together. So therefore, what is their relationship? We can say angle B1 plus angle B2 is equal to what? 180 degrees, right? Angles on a STR dot line. Okay. Any questions? Any burning questions? No burning questions. Okay. Now we're gonna look at one last thing. Properties of angles as they relate to lines. Properties of angles as they relate to lines. Okay, properties of angles as they relate to lines. So I want to look now at a very important but critical document, which I love specifically talking about as a maths teacher. 10 learners who are now in grade 9, right? Grade 9s, I need you to look at this document. This is a very important document, okay? I love exposing my learners in grade 9 to this document now already, because if you are a future potential grade 10 pure maths learner, this document needs to become your friend even now as a grade what? As a grade 9 learner. Very important, this document, okay? I want you to look at the very first statement there, okay? Or first and foremost, let's look at this. If you look at the top there, this says acceptable reasons, Euclidean geometry. And then if you look at the note before we get into the table, it says in order to have some kind of uniformity, the use of the following shortened versions of the theorem statements is encouraged. I repeat, in order to have some kind of uniformity, the use of the following shortened versions of the theorem statements are encouraged. So as a grade 9 learner, you are encouraged as well, okay? This document is really given to learners in grade 10 onwards, but You know, my grade 9 learners, when I teach them at school, I expose them to this document in grade 9 already. In fact, grade 8 already. All right. So these are important theorem statements. And if you look at the first few theorem statements, okay, statement 1 with the reason, statement 2, 3, 4, 5, 6, 7, 8, 9, 10. The first 10 statements are theorem statements that have to do with what? With lines. The first 10 statements have to do with lines. Okay? And so it is important to know what the statement says. And then for the purpose of answering questions that are geometry related questions, you need to know the reason, the correct acceptable reason that you should write as your reason. And so in grade 9 already, I encourage you guys to use this document. So I'm not going to today go into everything that's on this document. I'm just going to touch on the first, how many statements? Okay. 1, 2, 3, 4 statements. We're going to look at the first 4 statements, and then the rest we are going to look at another time. So for today, I'm going to look at the first 4 statements. Okay. So the first one statement, and I want you to also read it with me in your own space. The first statement says the adjacent angles on a straight line are what? A supplementary. Okay. And then if you look at the acceptable reason that is given there, all right, we have the symbol of angles on A, and then the STR for short line. Okay, don't worry, I'll definitely send it CF for life in the group. Definitely, no doubt. I mean, it goes without saying, I'll do that for you guys. Okay, but you can also take the liberty of screenshotting it if it is screenshotable, because that helps as well. The second statement says, if the adjacent angles are what? A supplementary. The outer arms of these angles, they form a straight line. Okay. And then you can see what the acceptable reason is for that particular theorem statement. The third statement says the adjacent angles in a revolution. Now we know what revolution angles are, all right, but they are saying the adjacent angles. So we are talking about angles that are adjacent, means angles that are next to each other, all right. The adjacent angles in a revolution, they do what? They add up to 360 degrees. And if you can see the acceptable reason that has been given there, there's angles around A, and then you have PT. Remember that PT stands for point. Okay. Or they say angles in a rev. So there's one of two reasons you can use as your reason. Okay, one of two. You can either use angles around a point or angles in a rev. Any of those two are fine. Any one of those two is fine. Then the last statement that I want to end on for today is the one that says vertically opposite angles are equal. And then they write the reason that is acceptable. And it's very clear. Okay. So just quickly to recap what we've just looked at. So we are looking at the properties of angles as they relate to lines. Okay. So there are certain properties specifically with regard to angles, which we basically find where lines are concerned. So the first one is that the adjacent angles on a straight line are what? Are supplementary. Remember, when we say that the adjacent, we are talking about angles next to each other on a what? On a straight line. Those angles that are next to each other on a straight line, they are supplementary. In other words, they add up. The word supplementary means add up to 180. They add up to 180. And guys, I'm sure you saw that the acceptable reason we use whenever we have to actually, we arrive at that particular conclusion and statement, we write this one that says angles on a STR line, right? This is a reason used whenever this statement is actually true. Okay, so I repeat, the adjacent angles on a straight line are supplementary. So if ever you have a straight line and you have, let's say this is B, you have 1 and 2, let's say A, B, C. What this simply means is that angle B1 and angle B2, okay, let's say this is D, sorry. This means that the adjacent angles on a straight line, meaning in other words, angle B1 and B2, they are angles next to each other, meaning they are adjacent each other. They are lying on a straight line. Those are what? Are supplementary. In other words, angle B1 plus angle B2 is equal to what? 180. And the reason we use is angles on a straight line. So that means we can solve, we can find certain unknown angles whenever we have angles on a straight line by simply using this theorem statement, which is important. I repeat, the adjacent angles on a straight line are supplementary. Okay. So in other words, angle B1 plus angle B2 is equal to 180 degrees. Reason, angles on a STR means for straight, and then we write line, right? And we could solve and find any unknown if there's a situation where angles on a straight line and we don't know one of the angles. 2, if the adjacent angles are supplementary, let's say that the angles that are lying on a particular line are actually 180, they add up to 180. Then what that means is that we can say that the outer arms of that particular angle, they actually form a straight line. So this is a statement we use whenever we want to prove that a line is actually a what? A straight line. That the arms of that particular segment form a straight line. Okay, this is the reason. That's how we prove a line is actually straight, and this is our reason. Adjacent angles sup. In other words, adjacent angles are supplementary. Okay, so I love usually doing this to my learners, and I usually do this to them, and I say to them, this is A, this is B, this is C, this is 1 and 2, and usually I say that this angle is 50 degrees, this one is 130, degrees. And then I superficially ask the question, is AB a straight line? I usually ask them that. Is AB a straight line? And then of course my learners, they look at that, and I'm sure even you guys, if I ask you, is AB a straight line? What do you guys have to say? Is AB a straight line? Yes or no? Okay, so I hope CR for life, that covers you there. Adjacent. So this is B1. This is an angle that is next to angle B2. So adjacent angles are B1, angle B1, and angle B2, next to each other. That's what the word adjacent means. Angles that are next to each other. So B1 and B2, angle B1 is next to angle B2. Okay, that's what we mean by adjacent angles. Okay. So I'm asking this question, guys, to all of you, and I'm hoping you can answer me. ACB, is this a straight line? When you look at this at first glance, is this a straight line, guys? Could we say this is straight? ACB. CR for life, no. Yikes. Yeah. All right. And CR for life, could you tell me why you're saying it's not straight? Why are you saying ACB is not a straight line? Hlumelo Twang is saying yes, but straight lines add up to 180. Niliwesa is saying yes because it add up to 180. So you see, if we look at the statement again, it says if the adjacent angles. Okay, so let's look at this. Which ones are the adjacent angles here? It's angle C1 and angle C2. What is angle C1? It's 50 degrees. What is angle C2? Is 130 degrees. Now the statement is saying if the adjacent angles are what? Supplementary. What does supplementary mean? CR for life. Do you remember what we were said the word supplementary means? The word supplementary means angles that add up to 180. So the statement is saying if the adjacent angles are supplementary, the outer arms of these angles. Now let me just note what the outer arms are. Okay. BC is an outer arm for this angle. AC is an outer arm for this angle. So this thing is saying if the adjacent angles are supplementary, the outer arms of these angles form a straight line. So I'm going to ask again, is ACB a straight line? Right? And maybe the question then you need to ask yourself is, according to this theorem, what is this theorem saying? If the adjacent angles are supplementary, the outer arms of these angles form a straight line. So I ask again, is ACB a straight line? Is ACB a straight line? Think again. Think McCain. So Nelly was saying yes. And the answer, guys, and this is not because visually we can see it's a straight line. No. It has nothing to do with visual. It has something to do with the theorem statement. This is something that is a true theorem statement, which means that if the angles that are next to each other, in other words, if the adjacent angles are supplementary, in other words, these two angles do add up to 180, do they? What's 50 plus 130? It's 180 degrees. Therefore, it says if the adjacent angles are supplementary, the outer arms of the angles form a straight line. So is ACB a straight line? Yes. ACB is a straight line. What is the reason? The reason is ADJ, meaning adjacent angles. Which adjacent angles? Angle B1 and B2. Adjacent angles Sup. What does sup mean? It means that the adjacent angles are supplementary, which means they add up to 180. So that's why we say ACB is a straight line. This statement is a statement we use whenever we need to prove that a line is straight. We check whether the adjacent angles for that particular line of what we perceive to be a line are actually adding up to 180. If they do, then it means the outer arms, they form a straight line. And this is the reason. Adjacent angles sup. And that's it. Okay, I hope we understand now this statement number 2 of the lines. Okay, very important. Okay, let's look at number 3, and then we'll look at number 4, and that will be the end of our session. Grade 9s, I'll end this session. We'll see each other on Saturday. Please, guys, take some time. Okay, I hope you've written down some notes and all of that stuff, but take some time to actually really internalize what we've done so far. The information and your understanding and the knowledge, the head knowledge of this, the heart knowledge of it is very important when we move on to the actual problems and we start solving unknowns, using the knowledge that we've gained. So please make sure that you understand all the angles, what they mean, and all of that stuff. Number 3, the adjacent angles in a revolution add up to 360. I repeat, the adjacent angles in a what? In a revolution. So let's look at this. Maybe you guys will appreciate. Let's say this is point P, this point there. That is 1, 2, 3, 4, 5. I'm sure you can see something here. Angle P1, angle P2, angle P3, angle P4, angle P5, all these are angles that are next to. 1 is next to 2, 2 is next to 3, 3 is next to 4, 4 is next to 5. And when they are next to each other, starting from this one, we move from here to there, that's that one. Then 3 is from here to there. Then 4 is there to here. 5 is there to here. 1 is back where we started. So I'm sure you can see these are angles around a point, angles in a revolution. So it says here that adjacent angles in a revolution, what do? They add up to 360 degrees. You have 2 reasons that you can use whenever you use that statement. Meaning you say angle P1 plus angle P2 plus angle P3 plus angle P4 plus angle P5, and you say it's equal to 360 degrees, then your reason in brackets, you can either say angles around a PT, or you can say angles in a rev. It's up to you which one you want to choose. Both reasons are acceptable, and these are the reasons we accept, guys, according to the revolution of angles. Okay. CR for life, it could be 2 angles, it could be 4 angles, it could be 7 angles, it could be 12 angles. It depends, right? Because look at this, as I said to you, okay, from here to there, from there to here, from here to there, from there to there, and from there back to where we started. That completes a full what? Circle from the beginning all the way next to the beginning. That's a revolution. So how many angles are we talking about? Talking about P1, angle P2, angle P3, angle P4, angle P5. We are back where we started. So that's why I'm saying these 5 angles in the situation are all angles that basically complete a circle. Revolution means a circle, so it must complete the entire thing. So that's why we say adjacent angles in a revolution. In a revolution means they complete one circle. Are what? Add up to 360. Okay, so it could be 5 angles, it could be 4 angles, it could be 2. It depends how many angles are around that point. Okay. Right, so if you're gonna say it must be 6, yeah, well, now you're imposing limitations that were never mentioned anyway. Okay, then the last thing I want to look at is the one that says vertically opposite angles are equal. The reason, vert op angles equal. So if we have, let's say, the letter M here, we have 1 and 3, 4 and 5. Okay. The reality is that there's a relationship that exists between angle M1 and angle M3. Okay. There's two lines that they are both straight. That's very important. They have to be two lines that are both straight. Like it has to be, this is a straight line, this is a straight line. Angle M1 and angle M3 are equal. And the reason that we state that they being equal is because of vertically opposite angles are equal. Angle M4, okay, angle M4 and angle M5, they are also equal. The reason is vert op angles equal. Okay, so today I'm gonna hold it right there, guys. Hold it right there for my grade beautiful 9s. Okay, maybe just before I say I'm gonna hold it right there, let's do this. I think let's do this very quickly. I wanna just check out a few examples. Okay, say this is A, B, C, that's F, we have X, we have 84 degrees. And the thing is that they are saying is here, find the letter X giving reasons. Okay, find the letter X giving reasons. Okay, so please let's note what we see here. We have line A, B, C. Line A, B, C. Underneath that line, we have this angle X, all right? And then from this line, this is 84, all right? So we have 84 degrees, we have X, right? If we look at from angle X to this line, okay? And then from this line, covering the 84, I'm sure you can see what I see, that this, from this here to there, that's angle A, that's X, that's the what I don't know, that's the letter I need to find. And then from here to there, it's 84. So this here is a complete, from this point to this point, the complete angle for everything, the total from here to there is what, guys? You tell me. You tell me. From here to there, the total for the angles should give me what? Because this is on a what? You tell me. What total should this give me? From here to there, Lesego, thank you so much. Lesego says 180 degrees. And I'm happy that you can say that, because we know that from here all the way back to, from here all the way to there, this is a straight line ABC. So this here is a straight angle. That means that these are two angles that are supplementary. And angles that lie on a straight line are what? Are supplementary. So what do we say here? X plus 84 degrees is equal to 180 degrees. What's the reason? Because we need the reason in order to be able to go ahead and solve at the end, you see? So X plus 84 degrees is equal to 180 degrees. So that's the statement, and then the reason that we need to have. Now we can solve for X. X is equal to 180 degrees minus 84 degrees, which is equal to 96. Okay. Okay. That example was not too shabby. It was very straightforward, straight to the point. And I hope that was very clear for us grade 9s. Okay. So that's one example. Let's look at another one. Okay. Okay. All right. So grade 11s, I'll be with you just shortly. Grade 11s, we're gonna have a session at 10. All right, and we'll continue with probability. Yeah, from where we left off from yesterday. Okay, I'm just wrapping up with the grade 9s here, so just hang in there. And obviously, the grade 11 probability that I'm doing is helpful for any grade 12 learner that is there, because grade 12s need to recap on the grade 11 work. All right, and obviously it will be later on after I'm done with the grade 11 work, in later sessions, not even today, not even tomorrow, not even the day after, that will be able to do grade 12 only probability. Okay, because I started with the probability a few days ago with grade 10 work. Then we've been busy now with grade 11 since yesterday. We started with the grade 11 work, and we'll be continuing with the grade 11 work tomorrow, the day after that, and so forth, until we get to the grade 12, which will be smack bang next week sometime. Okay, so we just need to be patient, because we are going in step by step with the probability there. So yeah, all right, let's look at this question. So once again, we have a straight line, two straight lines, and they cut each other, or they intersect each other at this point. We want to find the letters x, right? And we want to find y in this situation, and we want to give reasons for why we are finding those particular angles. So when we look at the 58 degrees and we look at the x, is there a relationship that exists between x and 58 degrees? Let's look at x and 58 degrees. We could look at the relationship between y and 58 degrees, and I'm sure you guys can see that there's also a relationship that exists between the y and the 58. Maybe let's ask first, what relationship exists between the x and the 58 degrees, if there is any, for lines? What relationship exists there? Okay, Mpo Raymond says op angles. Okay. Thank you, Lesejo. Lesejo says they are vertically opposite angles. James says so as well. So x and 58 degrees, guys, are vertically opposite angles. Remember, they are vertically opposite angles as long as the two lines that basically form these two angles are straight lines. Then we can clearly say this and that are vertically opposite angles. And what do we know about vertically opposite angles? They are equal. All right, so we can say x is equal to 58 degrees. This x is equal to 58 degrees. What's our reason? Vert op angles equal. So already we are using the acceptable reasons that is in that acceptable reason document, even now as a grade what? As a grade 9 learner. We are not wasting time. We are not waiting until grade 10 where we get exposed to the actual acceptable reasons, but we're starting to find comfort in using these reasons even now as grade 9 learners, which is important, right? Very, very important. Okay, so once we find that x is equal to 58, we can fill it in, because that's new information. Once we get an answer that's correct, we can update our diagram and fill in the information that we've just received, as long as it is correct and accurate. Now, why? We want the value of y. What relationship exists between this y and this 58? In actual fact, we can look at this 58 and this y as well. Okay, because the relationship that exists between this y and this 58, as well as alone with this y and this 58, is the same relationship. What do we see there, guys? From this y, this 58, from this line to there, right? And from there to the line. Thank you so much. Okay, Tiplo says, why don't we use revolution? Can we use revolution? We can't, guys, at this moment, because Revolution would mean 1, 2, 3, 4, and we have two angles that we don't know. So currently we can't, unless we can obviously state what this angle is using vertically opposite angles. If this is y, that would be y. Then we could use revolution and find the value of y using revolution. We could use that, no problem. Okay, we could do that. But I like what people have said in the comment section. Let's just check this out. The relationship that exists between y and 58, remember they are both on a straight line. And do they complete the straight line, the angles? From here to there, from there to here. That's completing the straight line. So together, these angles are supplementary, meaning they do what? They add up to 180. So we say y plus 58 degrees is equal to 180. Reason, angles on a line. Okay, so our statement, our reason as a grade 9 learner, and then we can solve for y. So y is equal to 180 degrees minus 58. So our value of y is what? What's 180 minus 58? 180 minus 58 is equal to, drum roll, 126 degrees. Okay. Now to the learner that said, couldn't we use revolution angles? The answer is yes, we could. That's another way we could find the answer. We could use revolution angles. Okay, but it would mean that what relationship exists between this angle and that angle? Okay. What relationship exists between that angle and that angle? We know this would be equal to y as well. Okay, so this would also be equal to y. Why? Because vertically opposite angle. So that's where we would start. We would say that's equal to y. All right. Hopefully we would be given the letters a, b, c, d, so that we could say angle sum is equal to that. Then we can say y plus this y plus the 58 degrees that we had found from the initial answer, plus another what? 58 degrees is equal to what? 360 degrees. Then we'd say what? Angles around a point, or angles in a rev. Doesn't matter which reason we utilize. Okay, but remember this, the previous thing of getting y is equal to y, that vert op angles equal. I mean, that's where we would start finding this y. Y is equal to y. Okay, but like I said, guys, we would have had those letters. That's a, b, c. So we'd say angle a, b, c is equal to y. Okay, vert op angles. Then we go ahead and say y plus 58 plus 58. Because remember, for angles around a point, we have to have everything. This angle plus this angle plus this angle plus that angle. We're starting here. That angle 58 plus that angle y plus that angle 58 back to where we started. Okay, and then we can solve 2y. 58 plus 58, of course, is 116. So 2y is equal to 360 minus 116 degrees. Then we would solve 360 minus 116. That gives us a nice answer. 360 minus 116. That gives us a nice answer of what? Isn't that 240? What is it? Okay, is this fine what we've done here? Y plus y plus 58 plus 58 is equal to 360. 2y plus 116. Is 58 plus 58 equal to 116? Do we agree? Yeah, 116 it is. Transpose. Oh, that's why someone was commenting in the comment section. Is it 126? That can't be 126. Okay, you see, in me, I took for granted that you guys gave me the right answer. 180 minus 58 can't be 126. Someone retype that. That should be 122 degrees. Now I understand. There was someone who was like 126. Lwando Vagele was like 126, no ways. So that was supposed to be 122. Okay. 180 minus 58 is 122. So someone typed in wrong. So 244, we divide both sides by 2. That gives us y, which is equal to 122 degrees. Okay. So thank you for that. Okay. Londo Vagele actually was spot on when they picked up that something is off about this 126. So it's supposed to be 122 degrees. Okay, so that's the answer. Y is equal to 122. Right. So those are just, like I said, grade 8 examples. And I would encourage you that if you do have a textbook, you do actually go back and, and this was just a few examples, for just the beginning, your angles on a straight line, vertically opposite angles, and angles around a point, so that we can start seeing how we use the statement, the reasons, how we write out the reasons, and ultimately how we are able to get to our various answers using that approach. Okay, so there we have it, done and dusted, and thank you so much. Okay, so I'm gonna end the live now, and I'm going to come back on for the grade 11 session on probability. We're gonna pick it up from where we left off. We were doing independent events. So we're gonna pick it up from there, the independent events. I think I actually gave you guys some homework to do. I left you guys with homework, so we can pick up from that homework and see how people were able to fare with that homework. I did say people must take pictures and so forth, so we'll pick it up from there. Let me end this live and I'll jump back on. Yeah.